Welcome to Study Loop.
Okay, this question says silver sulfate dissolves in water according to this reaction and tells us that the equilibrium constant with respect to concentration for this reaction is 1.1 times 10 to the negative fifth at 298 Kelvin. Then it tells us that we have a 1.5 liter solution containing 6.55 grams of dissolved silver sulfate. And then it asks us if we add additional silver sulfate, will it dissolve? And so there's some math that went into this before I got to this step that I'll explain, but it would take up a lot of space. We want to figure out the concentration of each of the products in this reaction so that we can get a reaction quotient to compare to the equilibrium constant. We're given the mass of silver sulfate, which is 6.55 grams. We can convert that to moles of silver sulfate by dividing 6.55 by the molar mass of silver sulfate, which is about 311 grams per mole. If you do that, you would find that there are about 0.021 moles of silver sulfate that were dissolved. Then you can convert that value to a concentration value, which is well, first you can take that number of moles and you can find out how many moles of each of the products there are. For every 1 mole of silver sulfate, there are 2 moles of silver and 1 mole of sulfate. So like I said, if there are 0.021 moles of silver sulfate, then there's 0.042 moles of silver, twice as many, or 0.021 moles of sulfate. Then you can divide that number by 1.5, the volume, because it's moles over volume, to get the concentration. So that one more time. You take the mass of silver sulfate, you convert it to moles of silver sulfate, then you convert moles of silver sulfate to moles of each of the products, and then you divide those numbers by the volume that this reaction is occurring in to get the concentration of each of the products. The concentration of silver we find is 0.028 molar, and the concentration of sulfate is 0.014 molar. We can then take these values and calculate the reaction quotient to see where we are in this reaction. And that is the concentration of the products, Ag plus, squared because there's a 2 here, times the concentration of SO42 minus, without, which is an exponent of 1, which I haven't shown. And normally you divide that by the reactants, but since the reactant is in the solid form, we don't include solids and liquids in reaction quotients and equilibrium constants. This is the entire equation. So we can plug in our values, 0.028 molar for the concentration of silver, 0.014 for the concentration of sulfate. We solve, we get a reaction quotient of 1.1 times 10 to the negative fifth. That, you'll notice, is the same as the equilibrium constant. So we would say that QC is equal to Kc. When the reaction quotient is equal to the equilibrium constant, we say that the reaction is already at equilibrium. And in the context of this question, that means that the solution is fully saturated with these ions. Therefore, when it asks if additional solid silver sulfate is added, will it dissolve? The answer is no. Since we're already at equilibrium here, no more solid can be put in to dissolve this. The reaction would want to move backwards if you added more to this. So no, additional silver sulfate would not dissolve.